Alright, so this particular lecture is regarding fuzzy relation operations. Now, first of all, we have understood what is crisp relation. Now we are going to understand what is fuzzy relation. So it's all about crisp set and then the fuzzy set, crisp operations, then the fuzzy operations. Then we studied the crisp relation and now the crisp fuzzy relation. Now, basically, what is fuzzy relation? Fuzzy relation is a fuzzy set defined on Cartesian product of crisp sets, that is x1 to xn. That means x1, x2 till xn, where there are n tuples. When I mean to say n tuples, I mean to say the rows. N tuples x1, x2, xn may have varying degree of membership within the relation. Now the first thing is, in fuzzy relation or in fuzzy set, what is the degree of membership we have? We have the degree of membership that is lying between 0 to 1, right? And in crisp sets, what is the relation? What is the membership function we have? We have the degree of truth that is either 0 or 1. Now, finally, everything depends on the degree of membership. Now, in the fuzzy relation, what we are saying that if there is a fuzzy set which is defined on Cartesian product, so we have to understand the Cartesian product in this concept. Membership function indicates the strength of the relation between the tuples. Okay, so let's take an example and understand what we are about to say, and what we need to say is, let R be the relation. We are saying let R be the relation. R is the name for the relation between two sets, that is x1 and x2. And these particular two sets are the fuzzy sets we are talking about. So we have a relation which is based on two sets, that is x1 and x2. Always remember, the relation will be based on two fuzzy sets when we are talking about fuzzy relation, and when we are talking about crisp relation, the relation of that particular crisp set will be dependent on two crisp sets. Fine. So what are these x1 and x2? First of all, we have in this example, let's say if x1 is the fuzzy set, which is the set of a disease, right? So we have the elements of this particular set are typhoid, viral fever and cold, just for an example. Next one, we have second set that is termed to be as x2, again a fuzzy set, is the set of the symptoms. So one set is for the disease and second set is the for one symptoms. Symptoms are, the first element is the running nose, high temperature and shivering. Now, when we define the relation on these particular two fuzzy sets, how do we define? We define it with the help of the membership function. And membership function defines the degree of relation between these two particular sets. Let's see how we have created the matrix. We have created the matrix as x1 and x2, where x1 being the row, right, and x2 being the columns. So you can see here x1 is what? X1 is a set of disease where I have written the typhoid, that is denoted by capital T, viral fever denoted by V, and then the cold denoted by C. Okay, then we have the next fuzzy set that is termed to be as x2. Now here we have made the rows, columns of this particular x2. What is this? Running nose, second is the high temperature, and third thing is the shivering, third element. So what we have done is we have created the matrix as x1 and x2 being the row and the column. Now we have the matrix as 0.1, 0.9, 0.8, 0.2, 0.9, 0.7, 0.9, 0.4 and 0.6. What does this mean actually? It means that when I say that if I have typhoid, the degree of membership of typhoid with the running nose is 0.1. That is, there is least possibility that with the disease typhoid you must be having a running nose. So there is very less probability, right? So that is why we are stating the degree of truth between 0 to 1. And you all know that the greater the degree of truth is, or the membership function is, the more it lies to that particular set. So here 0.1 is very less. So that is why we are saying running nose is less of a symptom of the typhoid. Next one we have high temperature. High temperature, it is denoted by 0 0.9. So what does 0.9 state? 0.9 states that if you have typhoid, there is a larger possibility or probability that you must be having a high temperature. Okay, then we have 0.8, that is for typhoid and shivering. Okay, so what does this mean? Again, it has a higher probability of shivering if you have typhoid. Now moving further, we have 0.2 as for the viral fever and the running nose. This is the probability of having running nose during the viral fever. Again, high temperature is the bigger or the larger probability of the symptom for the viral, and S you have 0.7. That means there are chances, there are quite possible chances that you have shivering during the viral fever. Now you can see the running nose has the maximum degree of truth with the cold. Obviously when you have cold you will be having the runny nose. So that is why you can see cold as the row and running nose as the column. This particular element is having the maximum relation between the two sets. And which is the least? Least is again the running nose with the typhoid. So this is how you read a matrix, or this is how you define the fuzzy relation on the basis of two fuzzy sets. Fine. Moving further, now we can see the fuzzy Cartesian product. What is this fuzzy Cartesian product? We have seen what is crisp Cartesian product. So it is the same way. Cartesian product is denoted with the help of cross. Let's say if I have a fuzzy set denoted by A, or always remember when we define the fuzzy set, it is defined with the help of a bar. While in the crisp set, we do not define it with the help of a bar. So A bar be a fuzzy set defined on a universe, that is X, and B bar be a fuzzy set defined on universe Y. Now the Cartesian product between the two fuzzy sets will be what? A and B is indicated with the help of A bar cross B bar. So this is how we are going to indicate the Cartesian product, which results in a fuzzy relation termed to be as R bar. So when we are doing the Cartesian product over two fuzzy sets, the resultant, that is A cross B, A bar cross B bar, will give you the relation, fuzzy relation, that is the R bar. So this is what we are going to figure out. R bar is equal to A bar cross B bar, where X cross Y is the superset for A bar cross B bar. So that means A bar cross B bar is the subset for X cross Y. And what is X cross Y? X cross Y is a universe relation. That means the universal set X and the universal set Y when done the Cartesian product. Now see where R bar has its membership function. This is for the membership function denotation given by, how do we denote it? We denote it with the help of membership function always in the fuzzy sets. So here it is a relation. So mu R bar subscription mein brackets X comma Y is equal to mu A bar cross B bar. Why A bar cross B bar? Because for the relation, what we have? Relation we have A cross B, that is the Cartesian product of two fuzzy sets. So mu A bar cross B bar brackets X comma Y. How do we define it? When we do the Cartesian product, we get what? We get it as minimum of mu A bar X comma mu B bar Y. That means that in the fuzzy set A, the element X, and in the fuzzy set B, the element Y. Among these, we have to find out the minimum. So that is what is going to be in the one. Now we have operations on fuzzy relation. As we have done the operation on fuzzy sets, operations on crisp sets, operation on crisp relation, same way we are going to do the operations on fuzzy relation. How do we do that? The main three operations on fuzzy relations are: the first one called as the union, the second one called as the intersection, and the third one called as the complement. So how do we define? For the union, we have every time you are going to find out the maximum out of the membership function of two sets. Here we are talking about two relations. Then intersection we are talking about being minimum out of the two relations. And lastly, the complement is being find out with the one minus that particular relation. So let's see how the formula goes for these union, intersection and complement. See, it is if you have two fuzzy relations, sorry, that is R bar and S bar. Be the fuzzy relation on X cross Y. That is the Cartesian product. Okay. Now, for union, you are going to say mu R bar union S bar brackets X comma Y. Just make sure that this particular mu and R bar union S bar is in subscription while X comma Y is in normal state. Is equal to what? It is equal to maximum of y maximum, because in union we do the maximum. Maximum of mu r relation x comma y comma mu s relation comma brackets x comma y. That is what the formula for union. Now next one is intersection. Intersection we have mu r bar intersection s bar x comma y is equal to what? We are going to use minimum out here for intersection. Minimum and the same thing, that is mu r bar x comma y comma mu s bar x comma y. So out of these we are going to find out minimum, I'll get intersection, and out of these I'm going to find maximum, I'll get union. Now moving further, we have complement. Complement the next operation in which we are going to do just one minus that particular relation. So we have mu r bar complement, that is C subscription में x comma y is equal to 1 minus mu r bar x comma y. So I don't think we have to explain it in the detail. You must have understood. Now moving further, we have the composition of relation. As we have done the composition of relation of crisp sets, we have crisp relation, we have the Maxman composition, and same in the fuzzy sets, the composition of relation, we have the Maxman composition. It is very much similar to the crisp Maxman relation. Let's see how it is. It is defining as composition of relations as Maxman. It is defined with the help of dot product kind of. That means R bar dot S bar is what? It is the composition of relations. What are the two relations? The two relations are the fuzzy relation denoted by R bar and S bar. The formula for this is going to be, this you have to remember, mu R bar dot S bar x comma z is equal to what? First of all, we are doing maximum, then minimum of mu r bar x comma y comma mu s bar x comma y, and then I am going to find the maximum out of these. So first thing I have to find out the minimum of these two, and then I have to find out the maximum out of the all, as we were doing in the earlier section of crisp relation Maxman operation. Now let's say we have R bar is a fuzzy relation which is based on x cross y, and S bar is a fuzzy relation based on y comma z. So R dot S will be what? It will be x dot, it will be x cross z. X cross z. What will be this? This will be R dot S. So R dot will be based on x cross z. Now we have, let's say we have capital X as x1, x2, x3 having 3 elements. Y is another one which is having y1, y2, 2 elements, and Z is another one that is having z1, z2 and z3 as 3 elements. Now we are going to see it with the help of an example again. Let R bar be fuzzy relation, and these two are the metrics how we are going to find out. Let's understand first of all how it goes. See what it is. Let's say we have three, as I told you, we have three sets, that is X, then the Y, and then the Z. These are the elements within these particular sets. So we are saying that R is a relation which is based or defined on X and Y. Okay. Then we are saying S is a fuzzy relation again. We are going to write R bar. S bar based on what? Defined on Y and Z. So when we are going to do the R dot S, R bar dot S bar, the composition of these two fuzzy relations, it will be defined on what? It will be defined on X and Z. That will be R dot S. Okay. So this is what here written is. A fuzzy relation is defined on X and Z. What is that? It is R dot S. Now what is the formula we have seen? We have seen that mu R dot S X comma Z. This you have understood. You must have understood why we are using X comma Z. Maximum of Y, minimum of, we should use brackets out here to make it a clear understanding. Minimum mu R X comma Y comma mu S Y comma Z. Let's take an example and understand what it is. One more thing, you can use this particular sign for the concept of and an or operation. Now see, we have, let's say, we have two sets. Okay. One is the R relation. Okay. Next one is the S relation. Try to understand it with this example. This is the row and these are the column. We have 3 rows and we have 4 columns out here in the R relation, and in the S relation we have 4 rows and being the 3 columns. So what we are going to do, we are going to find out and place in the formula, that was maximum formula. So first thing what we have to do is, the thing you remember always is, in the matrix what you are going to do, row with the column. Row with the column. So 0.1 we have to find out first the minimum of R mu R bar X comma Y, that means 1 comma A is 0.1. Let's take it with this position 0.1. Then we have S relation A comma alpha, that is the first element, as 0.9. So I have placed 0.9 out here. Then I have R relation first row second column element, that is 1b, it will be 0.2, so I have placed at 0.2. Then in the S relation I have a comma b comma alpha, so b comma alpha is 0.2, I'll place 0.2. Then I have R relation 1 comma C, so 1 comma C is 0.0, I have placed 0.0. And then I have in S relation C comma alpha. So C comma alpha is what? 0.8. So I have placed 0.8. Then I have 1 in R relation 1 comma D, and then in 1 comma D I have 1.0, so I have placed 1.0 here, and in S relation I have D comma alpha, that is equal to 0.4. So it is written at 0.4. Now what I am going to do is I am going to find out the minimum out of these. So out of 0.9, the minimum is 0.1. Out of 0.2, 0.2, minimum is 0.2. Out of 0.0, 0.8, minimum is 0.8. Out of 1.0 and 0.4, the minimum is 0.4. Now what I'm going to do is I'm going to find out the maximum of all these 4 elements. So you can just find out the maximum of 0.1, 0.2, 0.0 and 0.4 is as 0.4. So what I'm going to do, I'm going to define a new matrix, that is R dot S, with, if it has X comma X cross Y, R is having X cross Y, That means how many rows and columns? 3 rows and 4 columns. This matrix, this R relation is having 3 rows and 4 column, while S is having what? Y comma Z, Y cross Z, sorry. So it is having 4 rows and 3 columns. So finally your R dot will have what? It will have a matrix of 3 cross 3. That is X cross Z. Okay, so I have made a matrix of 3 cross 3, that is R dot S. I have placed the first element as 0.4 in this matrix. And this is what I am going to do for all the elements of matrix. So this is how we are going to find out the maximum composition and complete the matrix. That is what we have taken with the help of next example also. If we have fuzzy set R bar and S bar, we are going to find out R bar dot S bar, and we are going to find out all the relations between R dot S with the help of this. You can just see here in this particular R bar we have how many? 3 into 2, and S bar 2 into 3. So next R dot S matrix will be 3 into 3 matrix, and we are going to find out the complete composition. So thank you for this particular part, and next class we are going to continue with the next lecture.